In this video, the RTSync team presents how a well-defined modeling and simulation framework can support the decades-old problem in modeling and simulation support to achieve better and more efficient model-based system engineering and digital engineering infrastructure. The DEVS-based M&S framework toolchain, CAMLI environment, can provide the capabilities of flexible model composition, cost-saving model reuse, and faster collaborative development, which are the essential capabilities to support efficient MBSE and digital engineering. The Missile Defense Agency has been trying to address the decades-old problem in MBSE through programs like the Objective Simulation Framework, or OSF project. Model composability is one of the central MBSE problems for MDA M&S operations and the OSF project. Certainly, MDA has some ability to compose simulations today, but there are still stumbling blocks regarding the MDA's ability to do model composability rapidly, flexibly, and efficiently. Since M&S engineering and MBSE require new system models and simulations to work together with legacy models, model reusability was another critical support capability. As a result, a team of model developers, users, and testers has to work together, which requires a collaborative simulation architecture for the MDA MBSE operations. Through the SBIR 18-012 projects since 2018, the RTSync team has been selected to provide the CAMLI environment to address the M&S capabilities they needed for the OSF and other MBSE programs. The CAMLI environment was developed by extending RTSync's DEVS-based M&S software called MS4Me. The picture shows an overview of a ballistic missile defense system, or BMDS. We iteratively developed a BMDS model. We will use simplified examples of this BMDS architecture to demonstrate model and simulation composability, reusability, collaborative development, and integrative full lifecycle MBSE in the following video clips. Here, we show how we compose a simulation of a specific ballistic missile trajectory by selecting it from 24 possible ballistic trajectory simulation model compositions. This demonstrates model composability in the DEVS framework and CAMLI environment. Possible model couplings are defined in SCS files, which can be edited directly. Notice the DEVS outline to the right, or through a graphical sequence diagram. SCS files can be viewed using an SCS tree diagram, which you will notice below. Thus, SCS files can both be edited directly as text, viewed in an SCS tree diagram, or viewed in an outline. Using a graphical interface, SCS trees are pruned to create a PES, a specific coupled model configuration. Alternatively, a PES file can be manually edited. PES stands for Pruned Entity Structure. Here we are showing you the pruning process in our GUI. Notice the PES file that is generated. A PES file defines a specific model coupling, which can be automatically converted to a coupled model to be simulated. The simulation interface shows the coupling between models. The passed messages are shown for debugging purposes. The model shown here was entirely written by Chase Anderson from New Systems, who had no experience with MS4Me before this project. Another model developer engineer team used the same models and added a radar sensor model to the BMDS in the third example. This demonstrates a model composability and reusability in DEVS framework and CAMLI environment. The model developers can use the model browser and interfaces to enhance model development collaboration. This sequence diagram shows how the interceptor and sensor model are added to the overall system model. This sequence diagram is both a form of documentation, like traditional sequence diagrams, and a place where the actual wiring between models can be specified. Now, we show the integrated full life cycle of MBSE can be implemented in DEVS framework within the CAMLI environment. The diagram shows the full lifecycle MBSE solutions within DEVS framework. It uses fire control system design as an example. The connected lifecycle stages can support test and evaluation of end-to-end system design and its performance. Current MBSE technology solutions available in the market cannot support streamlined processes in a full cycle, including system architecture modeling, simulation, and analysis. The CAMLI MS4Me environment, based on DEVS framework, can support streamlined processes in a full cycle, including system architecture modeling, simulation, and analysis. Integration of DEVS-based hybrid system modeling capabilities into MS4Me can result in all-in-one capability improvements, eliminating the need to bring in other analytical tools like MATLAB and Simulink. The high degree of composability that DEVS enables means that instead of large monolithic simulation models, models can be composed of many smaller models. It is faster to develop many smaller models that can be composed in a predictable manner than one larger model. Each small model can be developed and tested independently. The cost savings for a single project is significant, but it becomes transformational when this approach to model development allows these individual models to be reused in future projects. The DEVS modeling formalism enables this Lego block approach to modeling. We are working to make collaborative model development more convenient by utilizing the model composability and model reusability that the DEVS modeling formalism provides. We envision a model repository that developers can upload and download models to. It will support robust verification, validation, and accreditation. Contractors could upload their models to a government-sponsored repository where they would be reused by other developers to reduce model development costs. Alternatively, a contractor could retain their models for in-house model reuse or license to other companies.